Hello, my name is Fred Tingey and I'm one of the founders of DeQuantifi, and today we're going to have a look at calculating VaR using a Monte-Carlo approach for crypto derivatives. Our goal today will be to generate a distribution like this showing P&L changes over a number of scenarios, in this case around 2,500, that have been generated from a multivariate distribution of a set of risk factors for crypto derivatives. We will calculate the VaR figure, which would appear in this red box, and at the same time, while we're about it, we'll calculate the expected shortfall, which is a variation on VaR where we take the mean of all of the 5% worst case scenarios. To calculate the Monte-Carlo VaR, we will load up some historic data. From that, we will infer for the different risk factors that we've identified what the changes are in those risk factors, then use that information to calibrate a multivariate distribution. Then we can sample as many times as we like from that distribution to get our changes in market data. And those changes in market data imply a change in P&L, giving us our scenarios that we will use in the VaR calculation. To start with, we will load up some historic market data, and that's fairly straightforward with DQTools. We have a historic market data database that we can access, and we'll be picking up around 300 days of history of changes in prices. You can see here we have for each day in the past and for each asset what the percentage change in price is. And in a similar vein, we'll load up our implied historic volatility data, and we can see for each scenario date and each option strike expiry what the implied vols were on that date. Using that information, we can figure out the changes in volatility for each day. So we've got our historic data, and then we need to calibrate our multivariate model so that we can use it for generating the scenarios. We have a class in DQTools specifically set up for that, and we pass in our price history and our vol history, and it will then go off and infer the multivariate distribution. Also, as part of that process, we need to define what risk factors we're going to use. So in this case, we're just picking a few expiry dates. So this is in days. And then we have our strike as a percentage of spot. So we've picked a few of those as well. There are two types of risk factors in our model. The first refers to the terms. So this gives us a term structure that's represented as a token, and then the number of days from today that risk factor applies. The second type, we have a token, and then we have a term, and then we have a strike, which is the percentage of spot. So that's represented in this fashion here. And that represents the change in volatility for a given number of days to expiry, and strike kind of in the moneyness, if you like. We can take a look at the means that have been calculated for these risk factors. So here we see the average changes for our Bitcoin futures, our Ethereum futures, our Bitcoin volatility surface, and our Ethereum volatility surface. At the same time, as part of the model, we also calculate the covariance matrix. So this is a square matrix, and the terms on the leading diagonal are the variances of each of our risk factors. And then on the off diagonal, we have the covariance between any pair of risk factors. Now, the important thing here, of course, is that we're including all the risk factors at the same time. So, for instance, we have the covariances between Bitcoin futures and Ethereum options. We also have the variances between different terms of the volatility surface. And so every single combination of risk factors is included in here. So the next step is to generate samples from that model that we have. We do that quite simply by just asking for a scenario. And here we can see one specific scenario, which tells us for every single risk factor what the percentage change is that needs to be applied. Now that we have our multivariate model and we can sample it for different scenarios, we can turn our attention to loading up the live positions and market data. That's really straightforward with DQTools. So here we're just loading up our exchange data and market data. Looking at the portfolio, we can run a valuation and we can see that this portfolio, well, it seems to only have deribit positions, and we've got a number of different futures, reverse futures, options and the like. Now we can get the current P&L from DQTools, and we see we have a P&L of about $2,180. In order to run the Monte Carlo simulations, I need to define a couple of helper functions first. What these will do is calculate the P&L change for any given scenario. So we take in the scenario and we take in our current live P&L, and then we work out what the shifts are required for the market data set. We apply those shifts and then we revalue the portfolio to get the change in P&L. So let's go ahead and do that. So here we're going to run 2,500 scenarios, and we're going to calculate the change in P&L using our helper function and create a collection of the results. And here we see for 2,500 scenarios what the changes in P&L are. It's a bit easier to see what's going on if we display the results as a histogram. Here we can see the green area represents all of those results in the bottom 5%, and the red area is where the actual 5% worst case lives. Plucking out the 95% confidence VaR is pretty straightforward, and that comes out to about minus $280. And the associated expected shortfall is the average of those 5% worst cases, and that comes out to about minus $360. So if you've stuck with me this far, then I think you'll agree that it's actually relatively straightforward to calculate a Monte Carlo VaR using DQTools. And this is due to the abstraction layers that our library provides around crypto derivative positions and market data. Using DQTools, we are able to analyze risk across multiple exchanges and tokens in aggregate or independently. DQTools comes with a number of risk reports, P&L reports, margin reports built in as standard. Using DQTools as a library or via our web API, it's possible to build your own custom reports quite easily. And we do integrate with CCXT, which gives us access to real-time position information across a plethora of exchanges. So if you'd like to find out more about what we can do, what services we can provide, then please do contact us at DeQuantifi.com. Thank you.